So it was a USDA project funded through APHIS and also the Department of Homeland Security to think about and develop some plans for how to manage mass depopulation in the event of a foreign disease outbreak, and with the goal of developing a system that could be used with off-the-shelf components and readily assembled in the field. I'd also like to acknowledge the participation of Murphy Brown and John Phillips back here in the back corner. He didn't want to be pointed out, but through working with them, when we started talking about this, we had some great ideas. Talked to John, and he would explain to me why it wouldn't work. And then when we got further down the project and we're ready to try some things, John said, "Come on down. We'll do whatever you need to set it up and do some evaluation." So I want to thank John for that and really appreciate that assistance. So just kind of what I hope to cover this morning, just define the problem, propose a possible solution. It's not the only solution, but it's one I think we felt like was usable, and then introduce some planning tools that we're developing, and that those will be available shortly on the web, to where you can go to pull those down and use them in your planning process and help you kind of work through what a process that will work in your situation. I'm not here to pretend like I have all the answers, because I certainly don't. I learned early on in my career in dealing with farmers and producers, you don't go tell them how to do something. You give them some ideas, get some feedback from them, and then develop a system together. So I hope that you'll help me with that again today. So if you have some ideas that you think if you can tell me why some of this won't work, or some things that might work better, I'd appreciate that. We'll have time at the end, I think. But I'd really encourage you to start thinking now about what you'll do if the situation arises, and then be prepared, and realize that every situation is different. And that's why I say I want to give you some ideas, but then you're going to have to put some thought into how you would make it work for you in your situation. To get us all on the same footing, just to kind of define what do we mean when we talk about mass depopulation. It's a method of putting down a large number of animals in response to a disease outbreak or some other reason, whether it's a disruption in the feed supply or some other logistical issue. But anyway, when you have to put down a large number of animals in a short period of time, it still needs to be done under as humane conditions as possible, but understanding that these are extenuating circumstances, and it may not be to the same level as we would hope under normal euthanasia situations. What we really developed was a system to use CO2, and I'll explain more as we go forwards. But it was really because of the readily availability of CO2. Does anybody use CO2 today? Okay, I figured a lot of you would. Carbonation in drinks, propellants, a lot of uses for CO2. There's trucks running up and down the road every day delivering CO2 to restaurants, convenience stores, you name it. It can be delivered, in bulk transfer trucks. So it's relatively low cost. It's a non-flammable, relatively safe gas. The biggest thing is it's a high pressure liquid, and so you've got to be careful in the handling of it. It also has anesthetic properties, so the actually pigs will actually go to sleep before they die, and if it gets concentration up to 60, 90%, it only takes about 14 to 30 seconds for unconsciousness, and then a couple of minutes for death. So it's relatively humane if it's done right. Concentrations below 30% aren't adverse to pigs. So if you raise that concentration slowly, and actually the AVMA requirement for euthanasia is a 5-minute volume. You'd be able to change that container volume, chamber volume within a 5-minute time period. The pigs don't really know what's going on until they're unconscious. And it is, CO2 is approved by both the AVMA and AASV as an approved method for euthanizing pigs. Then from a public or from a personnel standpoint, it is reversible. If a worker gets exposed to the CO2, they may get drowsy. If you get them out into the open air, they'll recover with no long-term effects, be about as normal as they were beforehand. So our objective was look at several things. We recognized the benefit of getting the animals out of the barn, that they'd be easier to manage for ultimate disposal outside the barn. You don't want to be killing a bunch of pigs in the barn, have to manually drag those out. And so we figured, well, why not walk the pigs out through the alleyways, use the loading chute, and then go from there. So we had to figure out how to do that, how we're going to do that in the field. And focusing on the CO2 gassing, we looked at developing alternatives for the actual containment. What are you going to put the animals in to administer the gas? We looked at trucks, above ground corrals, as well as pits. We also looked at just the flow rate. How do we get that low pressure CO2 gas that we need? If for small volumes, you can bleed off the headspace gas in the container, but if you're going with a large truck or a pit, you're going to have to utilize that liquid CO2, and there's some challenges associated with that that I'll go into a little bit. Then also, if you produce the gas, can you store it for later use, short-term storage? Also, we want to understand, how does CO2 react in a chamber? Is it going to be in at head height for the pigs? Are you going to get a lot of mixing in the chambers? So we did a lot of computer simulations and computational CFDs, computational fluid dynamics. It's a computer program that can analyze how gases and liquids move in a system. So we looked at distribution manifolds, also looking at the temperature of that gas coming in. You don't want to be humane, you don't want to freeze the pigs before they die. And so we looked at evaporators, heat exchangers to raise that gas temperature, earth tubes, just burying a tube in the ground to warm that gas up a little bit. As it's released, it's minus 70 degrees Fahrenheit. It's pretty cold coming out of the truck. And then also to achieve that 30% concentration in the chamber. Looking at the loss of riding reflex as an indication of unconsciousness, and then the time to death. Did a lot of simulation on. So what's going to be the limiting factor for in any situation? Is it going to be labor, the gas, CO2, trucks, or the chambers? And so we did some work with that, and I'll go into a lot of this as we go through the presentation. And then just general, to better understand the whole process and what alternative situations might arise. As always, the devil's in the detail. And like I said, every farm is going to be different. Every disease outbreak, depending on what it is, the response is going to be slightly different. Our goal was to have as much of the materials as possible readily available. Go down to your local hardware store, have the materials rather than having to stockpile a lot of expensive equipment or materials. What we've come up with, there's only really one specialized piece of hardware, and it's a brass connector to go from so that the CO2 truck has something to connect to your system with. And that's probably the only thing that you wouldn't be able to get locally. John, what did it take? I think you ordered some and took a week maybe to get it. So it's not out of the question to get it fairly quickly. The equipment company, folks that build the delivery trucks and all, it's a stock item, but it may take you a day or two to have one. So it might be something you'd want to have ahead of time. And also you'd want to talk to your supplier to make sure that your connection is the same as what their delivery trucks are going to be. Or depending on the truck size and the age of the truck, they've got 2 or 3 different sizes of fittings that they use. For the restaurants and all, it's a little bit smaller fitting. For the bulk tanks, it's this larger fitting. So you may, like I say, you want to talk with them ahead of time so that your fitting is compatible with theirs. We also wanted to document the methods and make sure that it was easy to apply for personnel. We didn't want something that was going to have to be a lot of training to go into ahead of time. Wanted it to be scalable, depending on the size of the farm or multiple farms. And then here again, as humane as possible under the conditions. So I'm going to talk about now the system that we came up with, and so this is kind of a how-to. Go through a couple of slides, kind of a how-to put together a system, what you need and how to do it. When CO2 is going to be used for euthanizing animals or for mass depopulation, size is important. To meet the AVMA requirements, you've got to be able to meet that container volume, whatever container you're using. You've got to be able to exchange that volume in that container within 5 minutes. CO2 is generally delivered as a high pressure liquid, as I've mentioned before. At low flow rates, you can just crack the valve and bleed off some gas into your a small container. But when you get to the high flow rates where you've going to be releasing the liquid, when you do that, about half the CO2 becomes a gas. The other half forms dry ice. If you've ever been around when CO2 is released, you see a fog. Well, that's small particles of dry ice. If you open that valve further, you'd actually get crystals of dry ice depositing on the ground. And that's fine. It's still usable. You could scoop that up and let it sublimate and go back into a gas, but that's going to take time to do that. So we wanted to, from a cost-saving standpoint, and utilize as much of the CO2 gas up front as possible. Wanted to see if we could sublimate that in through the process. So for a small scale, some of you may use these. This is a commercial product, Euthanex. They've got just the CO2 cylinder, a regulator, and a timer. So you put the piglets in the box, hit the start button, it opens the valve, and it just bleeds a small flow of CO2 gas out of that bottle into the box. So bigger version of that. So if you're wanted to go into a small trucks or trailers, came up with a system to take the liquid CO2 or take the high pressure CO2 liquid, discharge it into a second tank, to where it would be a low pressure CO2 gas, but still in container, and then flow from there into your container or your chamber through an orifice to control the flow to meet that 5-minute time frame. And so that in that secondary pressure tank, the CO2 gas, since you're bleeding it into a flow rate, it would be at a near ambient temperature. Schematically, it looks something like that. Your high pressure cylinder, a low pressure CO2 tank, a ball valve, an orifice plate, and then your chamber here. From a safety standpoint, we'd suggest putting in a pressure relief valve so you don't overpressurize that, depending on what you're using for your intermediate tank. It's generally going to be in the 20 to 30 PSI range. It's not high pressure, but you still want to be safe. Excuse me. In practice, it would look something like this: a high pressure cylinder. We used a small 250 gallon propane tank as their low pressure tank, an orifice plate mounted in there, quick connect fitting, just a washer about a 1/4 inch diameter. And you can calculate that or estimate it with some trial and error. and then then you flow through that orifice. It'll take 5 minutes for that tank to discharge through that orifice into the trailer here. And there's been a couple of companies that have, for on-farm use on a regular basis, for cull pigs, taken that idea, built them a trailer, you just load the pigs in, throw a tarp over the top, and then administer the CO2 through that system, similar to what I just showed you. There's another group down in Texas actually that working with the Fish and Wildlife, using a similar system for feral pigs that have been rounded up. So now, if you want to go bigger, this is when the challenges really get a little bigger. So we looked at farm grain trucks, roll-off dumpsters, above ground corrals, and that's just another view of that, where after the pigs would be loaded in, just throw the tarp over, put a drop pipe in for the gas to go in, and then and the final thing that we've looked at is using pits. Just so you dig a pit and use a tarp over, and the tarp is really, CO2 is heavier than air, so it's critical that the bottom of your container, whatever you're using, needs to be sealed. The top's not as critical, but you do want a tarp over it just to keep wind from washing out the CO2 as the level rises in the pins or in the chamber. And then there's also a washout port here. There's just a slit in that tarp, so that as you're putting the CO2 is going in, you've got to have an escape valve for the air that's already in the chamber. Yep, sorry. The ground is the bottom seal. There was a concern with whether you get enough permeability through the soil for the gas to escape. And thank you. And if you have questions as we go along, I don't mind at all. In fact, I enjoy that, and it makes it flow better than having to go back to something at the end. But yeah. So even in the sand, we did some tests with some pretty sandy soils, and even with those sandy soils, you don't get appreciable loss of CO2 through the soil. Yes. Well, and that would be a decision by the farm. There's no reason you couldn't, if you're at a site where you can, burial is going to be your ultimate disposal. There's no reason you couldn't do that. You may be, from an animal handling standpoint, you may want to push some dirt over the top of that first layer so the new pigs wouldn't see what's going to happen. But I don't know. I'm not a pig person, but yeah, I think would be a viable option. That's what I would certainly recommend. I say if that's going to be your final resting place anyway, you might as well do that. So you've got you know what your chamber's going to be. How are you going to get that gas then from the high pressure liquid into a gas state into the pit, their chamber? Well, we talked to Tomco Equipment Company that builds a lot of the trucks that the CO2 folks use for delivery. They said, yeah, we can design you a system with tanks and heat exchangers, vaporizers, $120,000 plus a trailer to haul it on. And oh, by the way, it's going to take a 60,000 kilowatt generator to operate it. And so you're another 25,000 for that. Well, we thought we could do a little better than that. So we developed our own vaporizer to capture and sublimate the dry ice. It looks this is the first version, looked something like that. It was a CO2 or a propane tank. Again, the one that we'd used in the previous low pressure situation. We said, okay, we'll recycle that. We put a heat exchange coil down here in the bottom so we can, as that gas comes out, said before, it's about minus 60, 70 degrees Fahrenheit. Run it through that heat exchanger and it'll warm that back up to near ambient temperature so we don't freeze the pigs. It's kind of what it looked like in practice. And I told one of my colleagues that I wanted something that somebody could put together pretty quick. And he came up with something like this, all dolled up. And I'll show you my version later on. But this was on wheels for portability and testing and all. It wouldn't have to be anywhere near this fancy. But it turned out we did it for about $2,500 and a 3.5 kilowatt generator for another $500. So for under $3,000, we came up with a system that would perform like the $150,000, $160,000 system. Here again, that's it. We're using here kerosene heaters. You could use propane, other heat sources, but by and large, figured most farms are going to have kerosene or diesel fuel, and those heaters are readily available. Problem with propane, especially if in the cold climates, as you know, when you use your propane grill, as it gets low, the pressure in the tank gets low, it starts freezing up. Well, at the rates we're running those heaters, those propane tanks freeze up pretty quick, and so kerosene heaters is probably a better bet. If you do want to store gas, so if you've got if you have trouble matching your flow rate from your vaporizer to your trucks, you can actually store that CO2 gas. We looked at making our own bladders out of just polyethylene sheets and tape, and it worked, but not all that well, especially when you get out in the sunlight. And well, both the heat and cold from the gas, the adhesive on the tape didn't hold very well. But then we looked at ag bags, silage storage bags, and you can get those in coming 100, 200 foot lengths and diameters up 16 feet or so. And they work great with some Gorilla Tape on the, just roll the ends up and Gorilla Tape on it. And fill it up like a big balloon. Got a giant chip clip made out of 2x4s and a hinge on one side of it, and just clamp it off to seal the end there. And then you can, when you get ready to go into your container, you can remove the chip clip and go from there. Now, this is my version, and what I would think would probably make more sense from a disaster response standpoint. Constructed it in the field in about, took two of us about 4 hours to assemble this one. And here's the schematic of it. Got the vaporizer unit, that cinder block enclosure just to help contain the heat, some to get better heat transfer into the vaporizer. So coming out of that, you're going to have a cold CO2 gas go back through a heat exchanger coil to warm the gas up, and then if you're using the option for this CO2 gas accumulation, the ag bag, and then through a regulation device to beat that 5-minute flow rate, and then on into your depopulation chamber. The vaporizer chamber, here again, we upsized actually to get more surface area so we could add another heater or 2 more heaters to the system. So we went to a 500-gallon tank and just dry stacked the block around it. And but you could use anything here as long as it's capable of handling that 500 or 600 degrees coming out of the tips of those heaters. We've used 55-gallon barrels as well as the propane tank. So it's, yes?
Are there any OSHA concerns you have to keep an eye on, and what sort of requirements?
Yeah, and the main thing here, since everything is supposed to be open to its atmospheric pressure, once you take that high pressure liquid from the tank, come through your fitting, and so right here, as soon as you're discharging it in there, it's going to be near ambient temperatures. So there's really not a pressure. It's not a pressure vessel as such. But if something were to happen, if somebody pinched the line or something happened, we here again would recommend putting a pressure relief valve on the system. The other thing, just from a personal safety standpoint, cryogenic gloves, because that line here. No, I don't think so. It's going to depend on this is not something that's going to be used on a regular basis. If it were, and that's part of the time codes that's built into the price of that system, is to make sure that they're covered from a liability standpoint. If this is something you're putting together yourself, and as long as you're using the appropriate fitting, the company's going to have a problem hooking to that, like I say, because as soon as it goes through that fitting, you're back at ambient temperatures. The biggest concern there is how cold that gas is, and so there again, gloves and goggles will be recommended. Any other questions as far as that? The heat enclosure, like I said, we just dry stacked the blocks, left holes for the heaters to set in, and then just the fittings. That's that fitting up here. You do need a valve of some sort. We used a hydraulic valve. It needs to be rated for both pressure and temperature, high or low temperature. And so we're using a needle valve, hydraulic pressure valve, because that is going to be subject to that. That's where that exchange is going to happen between the gas, the liquid, and going into the gas state. And so in that nozzle is where you're going to have that pressure relief, and the freezing, the coldest temperatures will be right there. We thought we could improve performance. We actually put a little elbow on the end of that, a little turnout, to try and get the gas to flow down the outside shell of that propane tank, but it really didn't make that much difference. You could drop it straight into the tank and it'll be fine. The heat exchanger, we just took a stainless steel flue pipe liner for a natural gas furnace or water heater, laid that on top of the tank, and then plumb that in. So your gas comes out of the tank. Part of the flow can go through your heat exchanger, and the other, with valves on each end, you can regulate the temperature of that gas just by feeling that line going into the chamber. The flow diagram, 2 valves, so you can open or close those 2 valves to regulate the temperature. Oops, sorry. You can regulate the temperature of the mixed gas at this point by how much of that gas you're actually taking through the heat exchanger. The gas accumulation, if you're going to do that, like I say, the ag bag, silage storage bag, works well, and we're able to get gas tight. You're only talking 1.5 psi in that storage bag, so it doesn't take much. And then the flow regulation, here again, if you experiment with it beforehand, you may not have to actually measure the flow, but if you wanted to measure the flow, I would recommend you either know how much you're flowing, so you can make sure you're meeting that requirement for that 5-minute exchange, or have a CO2 meter to know that you're getting the concentration in your chamber that you think you are. And it's easy enough to build a flow meter here. It's just a Venturi, and I've got there you go. You can take some PVC fittings. You've got a pressure difference in the pipe. You use just a water bubble level gauge to measure how much that pressure, what that pressure differential is between the two size pipes, and read that pressure difference on your water gauge. And there's charts available to say, so for each inch of water column, it tells you how many cubic feet per minute you're flowing through those sections of pipe. And the depopulation chamber, again, we talked about using either pits or trucks. The trucks modified the tailgates on as a standard dump truck or feed grain truck, so where this one was actually done with a slide gate, sliding horizontally. Some companies they thought their trucks were loading chutes would work better with a vertical. So anyway, modifying it, but you could to where then you can still use the dump feature when you get to the ultimate disposal side if you're going to have to haul them. And then for the gassing, all you'd really have to do is, as long as it's a solid bed in the truck, is once you get the pigs loaded on, run some great stuff foam or some sort of a sealer around that tailgate to seal the gas. Especially critical down at the bottom because CO2 is heavier than air. You get to where you're going to gas it, throw a tarp over it, throw the gas line in, and you're good to go. That was in looking at the studies on how that gas flows. Like I said, it flows pretty uniformly. You don't need a header to distribute it. You can put it in at one point, and as it fills, it'll distribute itself pretty uniformly and displace the air out of that around the top. No, for this, we were actually, depending on the size of the operation, we were actually connecting directly to a truck. That's a 7,000 pound capacity truck. Now you could use they have what they call mini bulk systems that they bring in on a skid mounted unit. And so that might be an option for you as well, to where you could bring it. They could have a mini bulk system, and then they could cycle trucks to that and keep that filled as you're discharging it. But here we were thinking we're close enough. Eastern North Carolina, we run trucks out of Wilmington, and they just cycle trucks in as we needed them. But here again, that's the logistics is the thing you need to be talking about with your suppliers now. The heat capacity is the other to meet your flow rate, and it works out that for each cubic foot of chamber volume, you're going to need about 600 BTU per hour heaters, and so you can calculate that out. If you're going to start, I generally say decide what you're going to use as a chamber. In this case, trucks or corrals, pits. Determine what that volume is going to be, just the length times the width times the depth of your container, and that'll give you your flow rate that you've got to meet that 5-minute flow rate, and then size the components accordingly, and realizing that you're going to need 600 BTUs per hour heat capacity for each cubic feet of chamber volume. Just an example of that, if we were going to do a pit that is 10 by 40 by 3 feet deep, gives you 1,200 cubic feet of volume that you've got to fill in 5 minutes. So you're going to have to be flowing at 240 cubic feet a minute of the CO2 gas. And then if you say, okay, multiply that by the 600 BTU per hour capacity, you need about 720,000 BTUs per hour. Depending on what heaters you've got, we were using 125,000 BTU per hour heaters, so we needed 6 of them to meet that flow rate for that pit. Pretty straightforward calculation. Now, to make it easier on everybody from a planning standpoint, we brought in a fellow, he's a PhD student in industrial engineering. His expertise was and his working on his dissertation was in modeling, simulation modeling. And so he put together a project to a tool that could be used both for strategic planning, so you could look at beforehand to develop the estimates of what resources might be required. But it also, from a tactical standpoint, you get in the middle of it, and where can you save or change things during the event to better manage the situation. And then that will be available on the web here shortly. He's working. Actually, I was hoping he was going to have it finished this week before I got here, but it's not quite ready. But it will be on the web, and I'll give you my contact information at the end that you can contact me, and I can get you the web address for that. But he modeled the system, and there's 4 distinct stages: moving the pigs from the loading chute, loading pigs onto the available trucks, preparing the trucks for gas application, and then the disposal. And of course, the important factor is time to completion of the process. And he looked at each process in detail. And so for moving the pigs, you're looking at the number of pigs, the weight class, how many houses, what are size, and how far is it. Here, where loading chute length, it's the average length from the pit or from the pen to the loading chute, where they're loading them on the trucks. How many workers are available, and then that all affects that time of each run. So the run's the time it takes to get pigs from the barn onto the trucks. Loading the truck, capacity of the trucks based on pig weight, and here's where the extenuating circumstances. These numbers are actually based on hauling capacity, or hauling rather than a depopulation situation. You could probably load them a little more densely than this in that situation, but these are also variables that you can change in the tool. Whether you've got more than one loading chute is also you can specify. And then preparing the trucks for each gas, you've got to just check the tarp, and then make sure that the bottom is sealed. Insert the hose. It's going to take about 5 minutes for the gassing to occur, and then that actually may take place. It could be a second location from where the gas is going to be, or it could be at the same location. Administering the gas. At the flow rate specified for the 5 minutes, and then applying that. When you apply that gas, as we talked about, you're using up your stock of gas. So if you run out, you're going to have to stop the process, or you have it set up ahead of time to where you can have additional trucks deliveries happening as you're going along. The sublimation that we talked about, like I say, instead of wasting that dry ice, if you can sublimate it as you're going along, you can extend that available gas stock. And then the disposal of the carcasses, and we didn't get into that. That's the other thing you do need to be thinking about, is what's that ultimate disposal going to be. If burial's an option, it would probably be the easiest, and especially working with this system. You do need about a 10-minute dwell time just to make sure that all those pigs are indeed dead. There may be one that's proficient at holding its breath for a longer period of time. So we'd recommend a 10-minute hold time, but that could be after it's left. If they're going somewhere else for ultimate disposal, that 10 minutes could be a part of the process. So you've got that ability to travel. You've already got a tarp on the truck, so it should be okay. And then the time it takes for the trucks to come back to the loading chute. That was just part of his simulation for his modeling work to show how that actually works, and the trucks. I'm not smart enough to figure out how to make it work, so I'll go on. So the parameters that you can, yes, sir.
With the CO2, was there causing the euthanasia, then you have to check for the sensibility and such? What's the plan then if there is one? At that point, if you're in there, you've kind of lost that. Like, this is the one. Like, we'll just use a cat hold or something like that.
Yeah, that's what I would suggest. Yes, and here again, it depends on what your ultimate disposal is going to be. If you're going to be in the pit, you've got somebody there monitoring it. You just go in and take care of that one animal. But yeah, you need some sort of a backup like that. So in the tool, you'll be able to input the farm parameters, the size, all the things we talked about, and the number of handlers, and then it will all that information stored in a database, and it gives, rather than having to have the expertise and the software to run those simulations, you put it all into this database, and then so when you use that tool, it refers to that all those simulation runs, but it's not actually running the model for every different situation. But it only takes a few seconds to run different scenarios, so you can look at different options in doing that. The sheet looks something like that. You just be able to put in the different the maximum time that you want to be able to put down the animals, how many houses, number of pigs per house, and the type of pigs, the truck sizes that you've got to use, how efficient are your handlers. So if you're in a situation where, on a normal operation, you've got people that know how to handle pigs, they're 90 to 95% efficient. If you in a situation here where you may have been bringing in workers from USDA or ag service that may not have the animal handling experience, that efficiency may go down. So you can play with that number and see how important that is, and then it'll give you that estimated time of for that process to be completed. Okay. So then on the output page, like I say, it'll give you the resources required to complete it in 24 hours. For 6 houses, it takes one team of 8 handlers and 4 trucks. Can do that in 24 hours. If you don't know what's going to be limiting, you can put in what you've got to work with, and it'll tell you how long it's going to take you. So if you work it both ways with that. So I think CO2 is a viable option. We can meet the AVMA requirements for pits, and you could use, if you need bigger pits, you could always put multiple units in, or just build a bigger unit than what I showed you. We're still working through some of the obstacles. Like I say, if you've got some concerns, I'd be glad to talk with you about them and learn from you. But the key thing is that most everything is available locally, and minimum number of people involved, and you're not have to handle individual animals like you would with captive bolt or other methods. Yes, sir.
I'm a veterinarian that has been involved in quite a few situations where pigs get gas. Thinking back to that and looking at your presentation, the biggest obstacle tends to be how heavy carcasses are handled to allow work.
Right.
Are you saying that these should be loaded on a roll-off type truck, filled, and then taken to a spot and dumped? Is that how you?
That's how I would envision it. Yes. Yeah. So your pigs walk onto the truck and you gas them. If you've got a dump, if you're using a dump truck type, then yeah, depending on what your ultimate disposal is going to be, you just go and dump them. And
so basically, you really want to retrofit a truck.
That'd be my suggestion. Unless you're going to use burial as the ultimate, and it happens to be there on site, then that would be the preferred method. But
the next thing, we're seeing in our areas with even if you're pulling a lot of those composting in the building.
All right.
So with hogs, it's a little different deal.
Right.
What do you think the EPA is going to allow? Are they going to allow digging a hole on a land site? There ain't a lot of carcasses involved. We had a fire one time 10 years ago. It took about a week to figure out where all the carcasses were going. We even had to talk about it.
Yeah.
Where do you think these carcasses will go in these animals?
I think it's going to depend on the disease. Where are the carcasses going to go is the question. I think it's going to depend on what that disease is and the transmittability of that. But I suspect burial, in some instances, in some places, burial will be an option. It's going to depend on the number of animals and lots of things, but I think burial will be an option. Another short-term option might be to windrow compost just until a better solution could be developed or come along. So it may be from a short-term standpoint, you may just windrow them out in a field with some carbon material and compost them. That kind of, it'll stop anything until you can then ultimately dispose of it